So let me share my screen. Confirm that you are able to see my screen. Okay. So last time we had our first session. Let me introduce myself. My name is Martin Ideche. I'm currently working for Nokia as a MPBN Paco SME, managing the Airtel MPBN network. And I also have to mention our sponsor. The sessions are sponsored by Life Technologies. That is a networking training and consultancy company. So we have our website here. You can find lots of articles on lab simulations on different vendors. We also have a YouTube channel. You can watch the videos, step-by-step guides on how to implement different technologies and different protocols on different vendors, Huawei, Cisco, Nokia, Juniper, and we will have many more videos published on our channel. So feel free to visit and also to subscribe to our channel. So we are ready to start our session. I'm already doing the recording of the session. I hope I'm clear enough just to confirm that before we begin our session. So in our last session, we discussed about the IPRAN network. We discussed also about the different transmission method that we can use from the radio to the network controllers. So this is the typical architecture of the IPRAN network. We already went through it. We mentioned the different nodes that we have on the IPRAN network. We have the access, we have the aggregation. So in these different layers of the network, we are deploying different types of equipment. We have the CSGs deployed on the access network. We have the ASGs, which we call the aggregation site gateways, and the radio site gateways deployed in the aggregation network. We have the radio side, we have the BTS, the E node B, the G node B for 5G. And then on the controller side, we have the RNC, BSC, MME, and even the EPC for the 4G network. We also have controllers for 5G network. We also have the NMS. Remember, when we are setting up this network, we need to be able to manage all these different nodes. We need to manage the radio equipments. We need to manage the RAN devices, the routers, the switches. We all need to be able to manage these nodes so that we can, for example, the KPIs, we can do the normal maintenance, software upgrades remotely without having to be on site. So that's the role that is played by the NMS. So of course, different vendors have their own NMS that can be used to do this managing of the equipments. So these are the names: CSG for the cell site gateway, ASG aggregation site gateway, RSG the radio site gateway. We have the BTS, the base transceiver station, BSC, the base station controller, RNC, radio network controller, and then MME, mobility management entity. So these are just some different entities you expect to find on the IPRAN network for service provider. So for the connection, you see that we have the radio equipments connecting to the CSGs, like the BTS, the E node B, and we also mentioned that nowadays we only do one connection. So we have the SRAN solution that we have one connection from the radio equipment. So it's just one equipment, one hardware, managing all these different technologies, 2G, 3G, 4G, and 5G. So they will connect to the CSGs, and then the CSGs will form a ring. It could be a ring, it could be a chain, it could be a star topology. We also discussed the different topologies, and then they are connecting to the aggregation node, the ASG. So the ASG forming part of the aggregation ring will also connect to the RSGs, and then RSGs connects to the BSC and RNC and all the other controllers. So we mentioned that sometimes there was a question last time Sometimes we can have the BTS connecting to the ASG. These are very common scenario. We also have some scenarios where you connect the BTS to the RSG. So it's allowed, it's something that we have in the network. So it, the standard solution define that the BTS should be connecting to the CSG, but some special scenarios you can always connect the BTS to the ASG or the RSG. So this is just an overview of our last session. I hope we are all in line. Unless there is any question from our last session that we need to cover before we start our today's session 2.
Hello, hello,
Yes,
hello.
yes, yes. Proceed.
Yes, yes. I'm sorry. I don't know. I just want to know if there is some record available for those who have missed the last session to go through and learn how has been discussed
Yes, yes.
during this last.
Last time there was a recording and it was shared, but I can also reshare the link once you. But if you visit the channel, you should be able to get the recording. Let me just put this one on the chat.
Okay, okay. Thank you.
Document.
The second question I have, which is regarding the different okay, on the IPRAN component, what are the difference between the ISG and the RSG? So, it possible to connect directly the site on the ISG?
Yes, that is also a case that we have. Sometimes, of course, it depends with how you want your network to be. Sometimes, like you see, in a location where we have the RSG, you don't want to
Yes.
have an ASG and also a CSG. So you end up having only this one equipment, the RSG, and if you have some access nodes, let me just go back to the presentation mode. If you have some access nodes that are here, this one could be a CSG that is connecting to the RSG. You just need to do some proper configuration and proper planning so that you can control the route advertisement and everything. Then you should be able to have your CSGs connecting to the RSG directly. It's possible and
Okay.
it's a very common scenario that we have even in production networks.
Okay.
The same way you can
Okay.
have a
Yes.
BTS connecting to the ASG, you can also have a RSG connecting to the CSG, forming a ring. Sometimes you can have a ring coming from RSG and terminating on the ASG. It's allowed and it's something that is implemented in the service provider networks. So you can have such a kind of a setup. You have a ring starting from the RSG and then terminating on the ASG. Yeah, it's possible.
Okay. Clear. Thank you.
Okay.
Hi, Mr. Martin.
Hi. Yes,
Hi.
yes, yes,
How are you? I have one question
yes,
in this topology. Sorry.
yes,
Is it possible that I have seen in some scenario
yes,
that if there is no RSG,
yes,
like in core side, they are using only ASG and the BSC, RNC, MME, and NMS, they are connected with ASG.
yes.
So, I mean, it's possible that if there is a network, there is no RSG. And ASG, also work as a ASG and also as a RSG.
Yes, it's possible also.
That is possible, right?
Yes, 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 yes. And it's
Bec-
also a very
Because
common scenario. Yes, proceed.
yes, I have seen that before I work in one network for one service provider. They have due to maintenance and cost issue, they
Yes,
have eliminated the RSG. They have dismantled the RSG and shipped this that type of traffic to ASG. So ASG and that scenario work is RSG and ASG both.
yes, yes. Some of these functionalities can be aggregated onto one device. As you mentioned, we can have the ASG acting as the RSG and connecting to the BSC and the RNC. It's also very common. because you've mentioned about the cost, because you see when you want to, the RSG are always big routers with big, high processing power, and they're expensive. So you can't afford to have RSGs in all location unless you are using, and you can use low-end devices as your aggregation devices. So many times you find that yes,
Yes.
we are using the ASG as the aggregation node also, and the ASG connects to the BSC and the RNC. But the standard solution,
Okay. Thank you. Thank you.
should be we have the CSG
Yes.
separate, we
Yes.
have the ASG, and then we have the RSG. But we end up having different variants depending on the customer network. I hope.
Yes. Yes. This is a standard solution you are providing. Yes.
Yes, yes, yes.
Okay.
But
Thank you.
all those variants are allowed, provided that you know how to configure properly, like you use the best practices when doing the configuration to ensure everything is working okay. Then you are allowed to do any variant of the standard solution. Last question, if there is any.
Yes. Hello, teacher.
Hello.
Yes. Uh, what is the representative of BE? BE. BE is a ASC is same
Which
RSG.
one? Which one? Which one?
RSG and BE are the same
BE.
work.
What is a BE? I'm not getting you. Can you?
BE provide internet. B provide internet.
Sometimes
This
different
is
vendors will give these devices different names. So this one could be, you see, like Huawei, they call it the RSG, the ASG. Some different vendors will come up with different names, but yeah, those are just semantics. So they could be the same device, just playing the same role, but given different names by the different vendors or different providers.
okay.
Yes.
Okay. Thank you. Thank you.
Okay, I hope we are good up to there. So our next discussion will be on IP address design for IPRAN network. So we know that, of course, when we are talking of IPRAN, there are some basic things that we need to do. Some of the basic things that we need to do is we need to configure IP addresses on our IPRAN network. So how many IP addresses do you configure? What subnets to use? How many different types of IP addresses do you need for you to be able to set up IPRAN network? So this is just a discussion on how you can do the IP address design for your IPRAN network. Some question to discuss. I hope we can come in, and the first question is, why do we need IP addressing on IPRAN network? Anyone who can respond to this? Why do we need IP address?
Yes, obviously, as the network is IP now, we need IP to connect all the node, the site node to core node to backhaul all the traffic to core node.
Yes, that's true. Anyone else who wants to share their opinion why we need IP address on IPRAN network? We're not seeing the chat, so if you have anything to, yes,
Yes.
yes.
Uh, for establish connectivity between PC and ASD or RSG.
Okay, that's true. So
That's need
yes.
that's need that's need for the IB.
Okay, yeah. So that's true. The first step, once you've done the installation of the IPRAN equipment, you've set up your hardware, you've ensured that you've done the cabling, you've established physical connections between different devices. For example, from CSG, you've connected a cable to the RSG or ASG, and then you have also connected your cable from, let me just use the pen. So you set up your site, the physical connection. You have a connection to the ASG connecting to the RSG. So we need some physical connection. You can have fiber, you can have microwave, whichever you have, the WDM, whichever mode of transmission that you are using. You also have a cable running from the CSG to the BTS. Now it's time to do some logical connection between these sites. That's where now we want to bring in the IP addressing. All these devices should be configured with some IPs. Remember, for any device, for example, if we were just to talk of the internet, for any device to access the internet, it should be having an IP address, and this is just a logical identity, kind of logical identity for this device. So we need some logical connectivity between these devices, and that's why we need to configure IP addresses on all these connections. So we'll be configuring IP addresses on these connections, and then we also need to manage this device. For us to be able to manage this device, we need also to give it a unique IP address so that we can be able to access it remotely from the NMS. So where to configure the IP addresses I mentioned, of course, the point-to-point connection between different nodes, we need to configure IP addresses. And then on the device itself, we also need to give it an identity. So we need to give it maybe a loopback 0 IP or a system IP, depending on the vendor, so that we can be able to manage this device remotely. So we have the point-to-point connection. Even for the BTS side, we also need to configure IP address between the BTS and the ATN. How many IPs depends on the different type of services that you are configuring from the BTS to the CSG. So how many IPs do we need for IPRAN network? Anyone who can discuss this? How many IPs do we need for IPRAN network, or how many IPs do you have for your IPRAN networks?
Hello. We
Yes.
can say three kind of IP address. One for user plane, the second one for control plan, and the third one is for NMS management and monitoring.
Okay. Thank you. Anyone else? How many IPs? Okay, I think you've mentioned the types of IP
Hello,
that you
hello,
need,
sir.
but now when we are looking at maybe the user plan, how many IPs do we need for the user plan? How many IPs do we need for the management plan? I also need an input on that.
Okay, I understand. When I come to the individual site, when I take one site, I need two IP because it is most of the time point-to-point connectivity.
Anyone else to?
Hello.
Hi.
Hi.
Hello, sir. How many IP address? It's depend of like services for the RAN set. If, for example, we have 2G, 3G, 4G, and 1M, we need, for example, like three subnets: one subnet for 2G, one subnet for 3G, and one subnet for 4G. And for management also, we need one subnet.
For the subnet, which subnet are you using? /24, /16,
slash
/8?
slash slash 30. We need two address like it's point to point. So we need two IP
Okay.
slash 30.
Okay. Anyone else? There are multiple people who are
Uh,
speaking.
I, it's
Yes,
like
yes.
it depends on network, but mostly service provider are using they are using private IP, and mostly this is a class A IP address 10.10 or something else like this. But then they subnet that's subnet further, like for point to point connectivity, like basic IGP reachability, like for ISIS OSPF point to point design, you can use a /30 subnet. Okay. And for range cited like 2G, 3G, 4G, it's depend on environment. You can mostly they are using like in some scenario they are using /29 subnet. And if they are using a VRP technology, like for redundancy,
Yes,
So
yes.
for sites that's they also can use that, but it's depend on network, how large, how many devices in your network. If that is large, then definitely there will be a more IP required. But in whole network, they are using a private IP subnets, and they further subnet that subnets according to the network design for point to point, or from CSG to our RAN site, and from ASG to ASG, from ASG to RSG, from RSG to our core P. So it depends on your topology environment.
Yes, 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 yes. It purely depends on your even the size of your network, how many services you have, how many sites, how many nodes, how many CSGs, how many connections. So that one will determine how many IPs that you want, how many IPs we need to be able to deploy our network. Okay, the next
Yes,
yes, yes,
sorry
yes,
to disturb Mr. Indeche.
yes.
Kindly check on the lobby if we have some people waiting to be let in to join the session.
Okay.
Thank you.
Anyone else who has a comment on the number of IP that we need before we move to the next point of discussion? Okay, so we'll move to the next point, how to do subnetting to ensure we have enough IPs. How many, of course, this one depends on the number of IP that you require, but I just wanted to hear from the team, how do you do subnetting for your IPRAN IP addressings? Which subnets do you use for the point-to-point connection? Which subnet do you use for the CSG to BTS connection? Which IP address subnets do you use for your RSG to the controller connections? Because whenever you are doing the subnetting, of course, you need to do it properly so that you ensure you have the enough IP that you need for deploying your entire network.
Hello, sir.
Yes.
Basically, we just need two IP address. So then we will use /30.
Why not /31?
No, /30 not is not allowed because, for example, if I must do one connection between 2G to gateway on router side, I must to put one address on, for example, on BTS BBU, and the gateway is on router. So I need two IP address.
Okay. Anyone else with a different opinion?
I think he is
Hello?
right. In slash 31, you have only two usable IP. One usable IP. So one IP you cannot use, like it's like not possible, because from one side, like if you are using for point to point pairing, then definitely require two usable IP, and
Yes.
that's only possible in slash 30 subnet 2 for 4. So it's a two usable IP in this slash 30 network, and you can use this. But if you are using slash 31, then you have not then you have only one IP.
No,
That's subnet not usable.
okay, okay. Anyone with a different opinion?
Uh, I, I need for two IB. One IB is point to point slash 30, and the, the another IB I use it for ASD or my customers connected, and depends on number of clients or hosts.
Yes, 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 definitely. It all depends on the number of the hosts that you're expecting and the number, the requirement. Like when you are doing the design, you always have to know how many IPs you need for the connection. If you are doing a connection to the BTS, you know how many IP the BTS will require, because you only need one IP for the
Yeah.
gateway on the CSG. But again, you need to know how many IPs you'll be configuring on the BTS end. Maybe you need the management IP, you need different service IPs, maybe you have different BBUs. So you need to have that in mind when you are doing your IP address design. The next question will be, how
Okay.
do we manage IP addresses on IPRAN? We know we have configured so many IPs on the network. We have thousands or even hundred thousands of IPs configured on the IPRAN network. So how do you manage these IPs, especially so that you ensure you don't have duplicate IPs? Anyone, how do you manage the IP addresses on IPRAN? Or you don't manage? Sorry.
For this, for to efficient management, we need definitely a tool for IP management like IPAM or something like that. But most of the time, we are using Excel sheet on which we store the IP that are located to on the network.
Okay, thank you. Any other input from the team? So yes, we need to, many times when you have the NMS, for example, if you are using, for example, the NFMP for Nokia, or you are using NCE for Huawei, many of these NMSs have the IP address management section, so you can easily manage them from the NMS. But if you don't have that functionality on the NMS, then you need to have something like a separate database for you to be able to manage these IPs. You can be having Excel sheets where you record all the usable IPs. And it's always a good practice that when you are doing this assignment of IPs, you have a proper record or a very clear record of which IP is used for what, which IP block is assigned to which region, which IP block is used for this service. So it's very easy, even when someone new is coming in, they are able to adopt the IP management system easily and be able to assign new IPs, because on a daily basis, we always need new IP addresses. You will need to integrate a new link, you will need to integrate a new node in the network. So you always have to be able to manage these IPs properly so that you know which ones are used, which one are free, and you are able to allocate new IPs very easily without causing IP duplicates in the network. The final item is, do we have IPv6 deployed on IPRAN? Anyone who has IPv6 configured on IPRAN, or who is planning to configure IPv6 addressing on IPRAN?
From my side, it is something that we have started, but not yet complete. But we have this on project. But it depends. We want to first of all finish IPv6 configuration on core nodes first.
You are in the plan of in the process of deploying IPv6 on your network.
Yes, 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 yes.
That's nice. Anyone else? If you have IPv6 deployed, or you're planning to deploy IPv6, anyone having SRv6 deployed on their IPRAN network?
Yes,
SRv6.
also SRVC also is part of the project because we are doing the cloudification on the network. We are moving on the cloud, moving the core network on the cloud infrastructure. So, we plan to to migrate the legacy IPMPLS to SRVCs.
Okay, that's nice. Very interesting. The last one before we move to the next slide. Anyone who have IPv6 deployed, planning to deploy SRv6, because the moment you deploy SRv6, then definitely you should be having IPv6 on your network. Okay, we move to the next
But
slide.
I have one question. Why the link IPv6 to SR segment routing? I don't understand why instead of saying that going step by step, like implement SR to know how it's working, have hands on it. Why sometimes I hear SRVC directly instead of SR first of all.
I think it's more of because you see, if you are moving to segment routing, you don't get. You see, the objective is to have the SRv6, right? Because it allows network programmability, the automation, and all those things that are best when you have SRv6. So you see, like segment routing, yes, we can have the normal SRMPLS, but again, it doesn't bring much benefits having SR-MPLS because you will migrate your network to SR-MPLS today. Tomorrow, you are still you start planning to migrate your network to segment routing for version 6. So you see, like if you can do it straight from the normal the legacy networks to SRv6, it will be even cheaper because when you are doing this migration, of course, you see when you are interrupting the network, you need to do the cutovers from when you are like there is always downtime involved when you are doing the migration from one technology to the other. So to avoid all those downtimes and even in terms of cost, you just do it once. You migrate from the legacy networks to SRv6. But of course, many service providers will choose to do it from the legacy networks to SR-MPLS segment routing, and then now they can evolve to segment routing for version 6.
Okay, understand. Thank you for.
Okay. Okay, we are moving to the next slide. So we've discussed about this, how many IPs you need. So this slide just gives an overview. Just, of course, you need more than this. So you know that we have a connection from the BTS to the CSG. This connection here. Many times you'll find we are using /29, sometimes even /31. It all depends on how many service IPs you require on this node. How many service IPs. If you require more, you can go to /28, you can go to /27, purely depending on how many IPs you require on the base station. Because for the gateway, we only need one IP to configure it at the gateway on the CSG. So many times it all depends on how many IPs you need on the service side. But the most common that I've seen is /29. You can have /30. Purely depends on how many IPs you need. So we have these different IPs. We have the system IPs or the management IPs. So every node is always assigned a specific, a unique system IP or the management IP that is used to manage the node. You need SNMP traps to be sent from the node to the NMS. You need to be able to log into this node remotely. You need to be able to configure BGP between these different nodes. Many times we are using the system IP for this purpose. So those are the system IPs. The point-to-point IPs, we are configuring them between these different nodes. You see we have here the point-to-point IP between the CSG and the ASG. We also have a point-to-point IP from the ASG to the RSG. So these many times for the networks I've worked on, we are always using /31 IPs unless we have seen others they use slash 30. It's also okay, so that you have two IPs available also. But majority of the point-to-point connection we normally use slash 31. So these are the point-to-point IPs. They are configured on the back-to-back connections between different devices. We can have another link going this way. Maybe we have another CSG here. We have another CSG or SG connecting back to this. We also need point-to-point IPs on these different links. You can be having a protection link all the way to the RSG. You also need to configure an IP address on this link. So these are the point-to-point IPs, just to ensure that we have connectivity between two nodes that are connected physically, or maybe through layer 2 VPNs, or any type of connection that is existing between two devices. So that's where you configure the point-to-point IPs. The third type of IP, these are the service IPs. So service IPs, now these are the ones that we are configuring between the BTS and the CSG, and also we also need IPs to configure between the RSG and the controllers. So there are service IPs configured on this end, on the RNC, on the BSC, on the EPC, SGSN, all those nodes, they need to be assigned IPs. So those are what I'm referring to as the service IPs. So how many service IPs you need also depends on the size of your network, how it's set up, and many other factors that you need to consider when you are doing your service deployment on your network. So these are the three IP that you need, and yeah, how many depends on the size of your network. Any input from anyone who has a question or an addition?
I have one question.
Yes.
Why are you put slash 31 subnet and point to point, like from one CSG to another CSG?
Yes, that's how for me the majority of the networks I've handled. That is the setup. We are using slash 31. You see, when you have, even for IPv6, when you are deploying IPv6, we will be using slash 127 or 127, so that you only have two IPs. And it's the most common that I've seen on many networks. You see, slash that one, you have two
I
IPs.
have, yes, you have two IP, but
Yes.
these two IP are we can use, like in this subnet there will be no broadcast IP, no
No,
network
no,
IP
no, no network IP, no broadcast IP. We just use the two available IPs.
towards side and slash one
Yes,
and,
yes,
and slash 31. There are two available IP. We can
yes,
use this.
yes, yes.
Okay.
We,
I
it's,
I I, I
yes,
thought that I think
you are
there is
breaking.
one network IP, and so there will be no usable IP.
No, we have two IPs. We have two usable IPs. We have, for example, if you see from my topology, if you see like we have 10.251.253.2 slash that one. So what we'll do is we'll configure this end, you configure .2, the other end you configure .3. That is it. You have a point-to-point link that is up. Because we require so many point-to-point IPs. If you are to use slash 30, okay, I know we have so many private IP that you can use, but again, if you are having so many, doesn't mean that you just misuse them. So for me, the most common I've seen on many networks, it's slash 31. You have 10.251.253.2. One end you configure .2, the other end you configure .3. So you have used the two IPs that are available in that subnet, and that is it. But I know we have other network that use slash 30, so that you have two available IPs. You still have the network IP, and you still have the host IP. I mean the broadcast IP. But given that we are running, why do we need a broadcast IP on a point-to-point link? We really don't need a broadcast IP.
Okay, got it. There is no need of broadcast.
Yes,
Yes.
yes, because it's just a point-to-point connection.
Yes, got it.
Yes. Any other issue? Any other question? Any other addition?
Okay, Martin.
Yes.
Can you use public IP in deployment of this or when setting up this IP for these devices?
I've never seen that. You see, we always mention about the public IPs, not so many. They are limited. You are only given few public IPs as a service provider, so you won't have enough public IPs. But if your network is small, maybe just covering maybe just few devices, and you have enough public IPs, you're okay to go ahead and use the public IPs. But for a service provider network, many times we stick to using the private IPs for these connections. You only have a public IP at the point of internet connection, or if you have some specific nodes, because there are always some specific node that needs to be accessed, and maybe you don't want to do nothing, then yes, you can go ahead and configure public IPs. But majority we use private IPs. Hope that is clear.
Yeah, that's clear.
So
Yes, for
inside
adding for
the
Yes, one by one. Hello? Someone was speaking.
so just for clarity,
Yes.
inside this entire topology would be using private IP addresses and not public IP addresses.
Yes.
Maybe to add on the public IP, private IP address thing,
Yes.
the aspect of limitation of public IPs and the usage of public IPs within the network exposes you to a lot because these things are advertised into the network, into the internet. I mean,
Yes.
but the private networks are within your private space, and then are netted into the internet over using maybe NATing into the internet. So the more you use public IPs within a small network, so also you kind of increase your security exposure to the network, the internet. So it's a complete thing in terms of security as well when you're doing this IP addressing and all.
Yes, I agree. That is true.
Yeah.
There is also the security aspect of it when you are using the private IPs. Thank you. Peter Karanja, you raising up your hand. Anyone else with a question? Peter Karanja, you are muted but raising up your hand.
Hi, Martin.
Hi, Peter.
Again, I wanted to add on the point-to-point scenario. We don't want to utilize so many IPs, so that's why we mostly use /31 IPs to
Yes,
avoid using so many IPs.
yes, because we need so many of these point-to-point connections, so we need to avoid misusing these IPs. So that is true. Thank you. The last person before we continue.
yes for adding for some uh, point to point using for Google caching and BGP for ISP internet service provider for point to point.
Yes, if we are doing the BGP from us, from the IPRAN network to other networks, definitely we'll be using
Yes,
the point-to-point IPs to
point.
establish this BGP connectivity. That is true also.
Yes,
Yes,
yes. Google and YouTube for when cache server uh, you need for point to point.
it depends. Yes. Any connection depends on the requirements. If you want
Yes,
to, and also it depends on the size of your network. If you have just two connections, you can go ahead and use /24 on
yes,
point-to-point connection. But if you just need to also take care of the other requirement, then yeah, you just go ahead and use what is required. You just use /31 or /30 for point-to-point connections.
Thank you. Thank you.
Thank you. Okay, so we move to the next slide. So, just an overview. We know that IPRAN network, we normally have different regions, and these different regions are isolated from the other region. If you've managed an IPRAN network, you know that is the scenario. So we'll have, for example, you can have IPRAN network in a given city or a given province or a given state. So these are what I'm calling the regions or the clusters. So you will have cluster 1, cluster 2, cluster 3. You have another cluster here. You have another cluster. And in these clusters, of course, you need to provision different links, different connections. So it's always a good practice that when you are designing your IP address planning, you can assign given blocks to given regions. It helps you even when you are troubleshooting your network. You know, when you see a given IP, you know it's coming from a given cluster. When you see a given service IP, you know this service IP, it's coming from a given cluster. So it makes even your troubleshooting easy. So that's why I've mentioned some of the best practices that you need. Let me see who wants to join. So once you have identified, because you can have multiple subnets, for different clusters. You will assign a given block on this region just for the system IPs. You will also go ahead and assign another block for the point-to-point connections. So you have point-to-point connection IP. You will assign another separate block for the service IP. So for the BTS to CSG connection, you also give it a specific subnet IP. So you end up having different IP subnet blocks for different regions. And I've mentioned that that one will help you to even easily troubleshoot, because you see, when you see this block 10.10.10.0/31, you see, oh, this one is coming from a given cluster. This one should not be coming to this region, or this one should be. So it's very easy to manage. It's very easy to identify different sites, different services based on the IP addresses, because you've done proper planning of your service and system, and even the point-to-point connection. So it's always recommended that when you are doing the planning, use separate, like assign specific blocks to specific regions or clusters. Another thing, we've mentioned that for the point-to-point connection, you use /31 for the point-to-point connection. This one helps to save on IPs, because a service provider network, you can be having so many connections. For example, if you are to talk of a service provider networks like Airtel, Safaricom, they have so many nodes, they have so many connections. So you need so many IPs to do this point-to-point connection. So you need to use /31 that will help you to save on IPs. Another thing is you need to have an IP management system or a database that will help you to properly manage these IPs. You've used so many IPs on your network. How do you ensure that you are not causing duplicates on your network? How do you ensure that the new IP that you have allocated has not been used in a given region? You know what IP duplicates can cause on the network. It can cause chaos. It can be messy sometimes. When you are having an IP, especially in the same segment, you have an IP configured on this node, and then you also have a similar IP configured on the other side. It could be messy. It could cause could be cause chaos on your network. So you need to be managing your IPs properly. Use the NMS if it supports IP management, or you have your own system that will be able to manage these IPs. Then you also have to continuously audit IP address usage on your network. So of course, when you have a proper management system, definitely you can do the auditing to identify whether you have any duplicate IPs, to identify whether some IPs have not been used. Maybe you allocated a given subnet here, and now someone is requesting for a new block. You need to be able to audit and see, oh, this block has been used, these IPs are still available, and let them use the available IPs without the need to assign a new IP address. For example, if you are using /31 for the point-to-point connection, then you need to ensure that all your IPs from 0 to 255 have been used before you go ahead to assign a new point-to-point IP block for this cluster. For the system IPs, we normally use /32 because you only need one IP for the management. So you need to also ensure that from 0 to 255, all these have been used for the system IPs. So when you have a proper IP auditing or management system, definitely this one will be very easy to manage and operate, and you will avoid IP duplicates in your network. Any question? Okay, so we move to the next slide. Now we are on the IGP. We have finished on IP address design. Anyone with a question on IP address design before we start our next topic?
Hello, Martin.
Hello.
So I would like to know for the P2P connection, we use public IP address. Is that why we need to use /31?
/21?
21.
31. Okay, no, we've mentioned that for the point-to-point connection within the IPRAN network, we are always using the private IPs. So we'll use private IPs for these connections. There was the security aspect. They are not propagated on the internet, so it's very secure to use the private IPs. So many times we are using private IPs on this connection. And a huge service provider, of course, I've mentioned that we have so many connections. So as much as we have so many private IPs, you still need to also use them efficiently. You don't just misuse because you have so many. So you need to also put that in consideration, that you need to use them efficiently. Because your network is still growing, your network could span multiple regions, and you will need more and more IPs. So from the start, you should be using the best practices. Use /31 for point-to-point connections. /30 also can be okay. For the services, of course, that one purely depends on how many services you have and the setup, the IP requirement that you need to set up for your network.
Okay, thank you.
Anything else? Anyone else with a question? Okay, we move to the next part. So we are now talking about the IGP design for IPRAN network. So IGP, the Interior Gateway Protocol, we know that we can use even static routes on the IPRAN network depending on how big your network is. But when we talk of the IGP, we are talking of a protocol that can be used to help us achieve dynamic routing within a given network, within a given autonomous system. So you can have a region, you can have a cluster, or you can have just an autonomous system, an AS, and then before you go ahead and start implementing other protocols like BGP, MPLS, what, you need to be able to have a dynamic protocol that will help you to have reachability between different nodes. So for the IGP protocol, purely used for the connectivity between different nodes, just to ensure that we have connectivity from node A to node B, so that when we are doing BGP on top of our network, we have reachability between the different nodes. So when we talk of IGP, why do we need dynamic routing protocols on our IPRAN network? Anyone who can come in? Why do we need?
Yes, Martin. I think we need an IGP on our IPRAN network. According to the knowledge I have, I think it's because you need to first set up BGP needs TCP connection, which IGP provides before setting up BGP.
Okay, that's true. Why don't we use static routes? Just discussing on the same concept, why we need dynamic routing protocols. Why don't we use the static routing protocol? Anyone who can
Hello.
yes, yes.
Dynamic routing is a very easy for common. One for routing is the best practice. When static routing for security is a very one. Yes.
Okay, thank you. Last comment.
Also, you may need a manual intervention in case you have to reroute traffic if you are using a static routing.
That's true. So we prefer always to use the dynamic routing because you don't want to do manual interventions whenever you have like a link failure or any failure in the network. You don't want to start doing manual interventions instead of just traffic rerouting itself. So that is the main reason why we go for the dynamic routing protocols. And we have different dynamic routing protocols. We have SIS, we have OSPF, we have BGP, we have EHRP, we have RIP. Those are just some different types of dynamic routing protocols. So when we talk of the dynamic routing protocol, there is also a classification whether it's IGP or EGP. So we have the interior gateway protocol and exterior gateway protocols. So which IGP protocol to use? Which one are you using in your network for the IGP? Anyone who can share the IGP they are using in their network and why you have chosen that IGP? I know we have OSPF and ISIS that are used for this type of connection. So which one are you using and why have you chosen to use OSPF or ISIS? Yes, yes, proceed.
ISIS, because ISIS is a little bit more scalable than OSPF when you look at scalability.
Okay, thank you. Anyone else with a different or an additional opinion on that? Why are you using ISIS and not OSPF? Or why are you using OSPF and not ISIS on your IPRAN network? I'm sure we all have these protocols running on our network. For those one who are working on service provider networks, especially for the carrier networks.
Yeah.
Okay, so for this session, we are primarily looking at ISIS. ISIS, what does ISIS stand for? Anyone who can give us an introduction to ISIS before we dive deep into design, because this class is more of advanced, because we are looking at application of ISIS on IPRAN network, so we may not go deep into those details. So what does ISIS stand for? And anyone who can give us an introduction to ISIS protocol? Yes, Emmanuel.
Okay. I think the ISS is largely on, it's called intermediate system to intermediate system. Huh?
Yes.
Summarily, I would say it uses link state packets to route packets. So dependent on the interface, it's not IP dependent. That's the summary I can give for now. Yeah, it uses link state information to route packets, and it's largely not IP dependent, it's interface dependent.
Okay, thank you. Anyone else? Anyone else? Anyone else? With an addition? Yes. Okay, so ISIS, it's a link state protocol. It's same as OSPF. It's also a link state protocol. So when we go to now the ISIS design, there are some key concepts that we need to have in mind when we are designing ISIS for our IPRAN network. You can see that in this setup we have different rings. We have access ring 1, we have access ring 2, we have chains, and we also have the star or the spar topology for these nodes. So when you are designing ISIS for your network, there are some key concepts that you need to have in mind. The first one is on the ISIS areas and levels. So we know ISIS supports different levels. We have level 1, level 1, 2, and level 2. So you need to know which level are you using for your IPRA network, and which area are you setting up for different access rings or even the chain and the spar and even the aggregation ring. Which ISIS area are you configuring for your network? Another thing that you also need to have in mind is ISIS network types. So which network type are you configuring on your ISIS network? That is something that you need to have in mind. And once you've segmented your network into access and aggregation, you also need to ensure that these two processes can interact. Because remember, once you've set them into two different access and aggregation processes, you still have to ensure that this CSG can communicate to the loopback IP of the ASG. This ASG should be able to communicate with the loopback IP of the RSG. But if they are in the different areas, then how do you achieve the connectivity between the different processes, the access and aggregation processes? So that's why we have the access and aggregation route import between the two processes. Another thing, the network entity. How do you generate your network entity for the different nodes in your network? Then node ISIS name. Are you going to configure the node ISIS name or not? Of course, this one has a very important usage, especially when you are troubleshooting. You can view the node name when you are displaying the ISIS adjacency or the ISIS peering session. Then authentication. Nowadays, we are always talking about the network security. Are you implementing the authentication for this ISIS protocol? And which method are you going for? Are you using the symbol one? Are you using the MD5? Are you going to use the keys? And which one? Are you going to do the domain authentication, area authentication, or interface authentication? So these are some concepts that you need to consider. Another thing is that we also have to consider about the IGP to LDP synchronization. So remember, LDP works closely with MPLS, and then we need to ensure that there is a synchronization between our IGP, which is ISIS or OSPF, and then with the LDP protocol, so that when a link is down and it recovers, do we have the synchronization between the two protocols before we can start switching our traffic to the backup path? And then BFD for IGP. All these IGP protocols, they support BFD. So it's always a good practice when you can implement BFD, bidirectional forwarding detection, for quick detection of faults on your network. So these are just some few concepts that we'll be going through in the next slides, just to make us understand how you can go ahead and do a proper planning for your ISIS protocol for IPRAN network. So to the next slide, we know that the first concept was about the ISIS areas and levels. So we know that ISIS has different levels. I've mentioned that we have level 1, level 1, 2, and level 2. So level 2, kind of the backbone. SPF, of course, you have the backbone routers. And then we have level 1, 2, kind of the ABRs, SPF, connecting different areas. And then we have level 1, kind of the non-backbone routers in OSPF. So it's always a good practice that when you are setting up your network, you need to divide the network into different areas. And then on IPRAN, mainly we use level 2. So we'll set up our network. All the routers will be configured as level 2 routers. So they are part of the backbone. They are able to exchange all the routing information without any limitation. So many times we use level 2 and then we set up our network into different areas. So from this setup, you can see that we have access ring 1. We'll be configuring this access ring 1 in a given maybe ISIS2. This one will be configured in ISIS1. Given that this node, the span nodes are spanning from this router, so they will be part of ISIS process 1 or area 1. And then for this chain, we can also create a separate ISIS process or a separate area for these chain nodes. And then the aggregation, we also put them in a separate ISIS area. So you are reducing like the flooding. When there is flooding of these protocol messages, you are reducing the flooding that will be happening for different. If you are to put all these nodes into one ISIS process. It's like you have created one broadcast domain, and you know the issues caused by the broadcast in the network. So that's why it's always recommended that you need to go ahead and segment your network into different areas. Every ring, access ring or aggregation ring should be in a separate IGP process. And then you need, of course, to consider the route importation between the different processes. We'll be looking at that later. And many times we always go for level 2 for our ISIS deployment on IPRAN. I've mentioned about the network entity. So when you are configuring OSPF, ISIS on your network, there is always a unique identifier that is used to identify every node on the network. That is what we are calling the network entity on the network. So these are we say that is special form of a network service point, the network service access point, and it must be configured for the peering to come up. And these are the components. We have area ID, system ID. The system ID we normally generate it from the loopback IP. And then we have the selector. This one, of course, it's always set to 0. This one has a separate use on the OSI models, but for the ISIS protocol, it will always be 00. So this is how, and many times we always generate it from the loopback IP. I hope that is same on your end, unless there is a different opinion on this network entity. How do you normally generate it on your end? Anyone with an input on this? Do you generate it from loopback 0 or you generate it randomly on your networks?
I think best practice is to always generate it from loopback 0.
Yes, I agree. Anyone wanting to join? Let me just admit them. So that is the network entity. The next part, we have the ISIS cost design. So when we are doing ISIS configuration on the network, we have how ISIS select the best route. It will always decide based on the cost. So when you are doing cost planning on your network, you always have to do proper planning to ensure that there is optimal routing of traffic. Ensure that the best or the optimal route selection will always select the best path on your network. So we have different types of cost style. Of course, we have the narrow, we have the wide. Many times when you are setting up the IPRAN network, you always set the cost type to be wide. And then when you are doing the cost configuration, so we have by default, of course, it will be 10. You want to highlight. By default, the interface cost is set to 10. But then we have different ways or different modes that you can decide the cost. So this is in descending order. So you can have the interface cost. This one is configured for a specified interface. So you have a connection between two devices. You manually configure cost on this end. And when you configure here 100, don't go ahead and configure 200 on this other end. That's not a best practice. When you configure 100 this side, go ahead and also configure a cost of 100 on this other end so that it's metric. Then we have the second one. You can have the global cost that is configured for all interfaces, and then see it's automatically calculated cost. So this is how you calculate it. The bandwidth reference out of the interface bandwidth times 10, almost similar to how OSPF calculate the cost. So we have a similar formula for ISIS. Many times on IPRAN network, we always recommend that you either manually configure the cost. This one is always the best option, or you can have the bandwidth reference value configured. But when you are doing this bandwidth reference, of course, you need to factor in the capacities in your network. For example, if you have 10G, 100G, 200G links, you also have to factor in the link capacities on your network so that you can be able to make when the cost selection, when the route selection is happening, we will select the best one, not like you have a 1G and a 10G, and given that they have similar cost based on what value you've configured on your bandwidth reference, we end up having traffic using the 1G link instead of 10G link. So when you are doing this bandwidth reference, you always have to consider the cost capacities on your links. I mean, the link capacities on your network. But many times what I've seen is we are manually configuring the cost on our IPRAN links. Which values to use? This one purely depends on the requirements on your network or how it's designed. Many times for the aggregation link connection, you can set a cost of 50. So this one is just a sample, but it purely depends on your network. You can go ahead and use 100 here, use 200 here, depending on the network and also the requirement, the design requirements of your network. But many times we can have, you can see that between the RSGs we have low cost, and then when you go outward the cost increases. So you can have 50 configured between the SGs, you have 10 configured between the RSGs, you have 100 configured between the SG and the CSGs, and also between the CSGs you have a similar cost of 100. So you end up having like you need to do proper planning of the cost, and when you decide that you are going to configure 50 in the aggregation, then keep it 50, unless you are doing some a manual switch off of traffic that you want to configure 200 on this one and also 200 on this node. And I've also mentioned that one of the best practices is you always have to ensure that you have uniform cost configured on both ends of the link. If you have 100, also configure 100. Don't configure 1000 this side and then 100 on the other side, because you need to have symmetric cost on your links. How do you configure? These are sample on how to do cost configurations on Huawei. So for the interface configuration, you just set ISIS cost and then you set it to 100. So we have to be under this interface and we set the ISIS cost to 100. This is how you set the interface cost. For automatic cost calculation, you can see that we are setting the reference bandwidth to, this is 10 million, and then we auto cost enable. So the cost will be calculated based on the bandwidth reference. And then the cost style, we are also setting it to wide. For global cost, you set the circuit cost and then cost 100 under the ISIS processes. So these are just some different ways in which you can configure ISIS cost on your network. Of course, later we'll have a lab simulation, and then we will do a lab. We can do one on Huawei, another one on Nokia, just to put in practice what we are discussing now. But that one will come later. Any question on cost or any input? Anyone who has an input on this before we move to the next slide?
Yes. How to calculate the cost?
How to calculate the what?
Cost depends on the if I have a SFB 10G
Yes.
and want to connect to another site 100G.
Yes.
For what is cost of need I needed?
Have mentioned that this one purely depends on the standard. Like you see, when you joining a company, they always have the normal. Like they have their standard. They have specified that this link between the CSG and the CSG should be configured with a cost of 1,000. Then yes, that's what you should adopt. There is no standard definition of which cost to configure. You just need to do proper planning of the cost between different nodes, between the CSGs and the CSGs, between the RSGs, between the CSGs and the aggregation nodes. So you just need to do a proper planning to ensure that you have optimal flow of the traffic. But there is no standard like you should configure 10, 100, or 1. No, no, no. It purely
Yes,
depends
thank you.
on your.
Depends on your what you need.
Yes, yes.
Yeah,
But
yes,
there is
yes, thank you.
always a setter, there is always
1G,
a standard
small
that is
1G.
set up by the company.
Yes, okay, thank you.
Okay, just an addition.
Yes.
So we have the cost style being wide and being narrow. So if you use narrow, you can just play with cost between 0 to 63. But if you use wide, you can play from, I think, 1 to 16 million and something. Another
Yes,
thing
yes.
is also if you are to use a bandwidth reference, I don't think this could be a best practice because actually we don't really play on cost only depending on the capacity, but also we may need to play on cost whenever we are considering maybe we're using the links that are much stable. They could be having less capacity, yes, but they're much stable than the other ones that they have high capacity. So I'd prefer maybe you do the cost manually other than using the bandwidth reference.
Yes, yes, I agree. That's why majority of the service provider, they go ahead and use the manual configuration on the interface. And if you have all these options configured, it's always the interface cost takes precedence. The global cost follows, and then we have the automatically calculated cost. Many times we recommend manually configuring the cost so that you know what is configured, and it's very easy to know the costs between the different nodes depending on what is configured manually instead of using the bandwidth reference, because someone may not know, like you can just not, you won't be able to know the cost of head. So that's why we end up having to recommend the manual cost configuration on the interfaces. Thank you, Theo, for the addition.
Yes, why need network entity for when represent for ISIs? When I configure the OSPF, no need the network entity, but ISS needed for network entity. What's perform?
OSPF, you have the router
Network
ID,
entity.
right? When you are configuring OSPF, you always configure the router ID.
Yes.
Yes, yes. So you can take the network entity as kind of the router ID for ISIS. Okay, Sahi.
Thank you. Thank you, Tija.
Okay,
Thank you.
we move to the next slide. We almost we need to go with speed so that we save on time. So yeah, the interface type, when you are deploying SIS, another thing that you need to configure is on the interface type. So we have two interface types. We have broadcast and point-to-point. Many times these are point-to-point connections. So we always recommend that you should set up your point-to-point connection into the point-to-point network type. So this one will help to improve the convergence time of the SIS network. You don't need to elect the DIS on a point-to-point network, so the convergence speed will be much faster. When you have the broadcast, of course, you have the DR, BDR, I mean, when it comes to SPF, but for SIS, we only have the DIS. So you have to elect the DIS whenever you have SIS coming up. So this one wastes some time. But for you to also improve the convergence, you just set your point-to-point connection into point-to-point network type, and then you are good to go. No need to have the DIS election. So we always recommend to have point-to-point connection. And then when you configure the network type on one side of the link, like you have a CSG connecting the two nodes, you have configured the network type. So if you don't configure network type, by default, we have the broadcast. So when you configure this side to be a point-to-point, you also have to configure this side to be point-to-point. Make it symmetric. If you have point-to-point, have point-to-point on the other side. If you have broadcast, then make sure that you have broadcast network on both sides of the link. So another thing that we need to look at is SIS IGP to LDP synchronization. So we know that we have MPLS deployed on our network, and it's using the label distribution protocol LDP to assign labels on our network, and you end up having primary and backup LSPs. So when there is switching of traffic between these primary and backup LSPs, of course, maybe there is a failure in the network and you want to switch your traffic from primary to backup. And then when the when the primary link restores, and then the traffic switches immediately to the primary link, you may end up having issues in your network. That's why we need to have IGP to LDP synchronization to ensure that the link is ready to carry traffic before you can switch traffic to that link. So you always have to implement this IGP to LDP synchronization to ensure that you don't have downtime or traffic interruption when you have the switch off of traffic from primary to backup LSPs. So we have two modes. You can configure it in the interface view, or you can also do it within the process. So these are the two modes in which you can configure the IGP to LDP synchronization, a very important feature that you cannot avoid when you are doing your implementation, especially when you have this LDP and MPLS in your network. It will help you to avoid the downtimes. The next thing is so we have the access ring, we have the aggregation ring. You always have to do some route import. I mentioned that when you have your CSG here, this CSG should be able to reach the loopback IP of this SG before you can go ahead and implement things like BGP, or even when you're establishing LDP session, they will be established using the system IPs. So you need to go ahead and ensure that you have route import between the two processes, the access and aggregation SIS processes. And for you to be able to do this, you can see that we have the access ring and you have the aggregation ring. So we are importing routes from the aggregation ring to the access, and we are also doing the same from access ring to the aggregation. I've never seen a scenario where we are importing routes from access to access. This one will cause chaos in the network. It will be chaos because you can have loops when you do that. So that's why you always have to do it at the boundary between the access and the aggregation. And the objective of having these processes into different areas is to ensure that they don't interact. So when you do route import between the two, then why are you segmenting your network into different processes? Instead of having access to access importation of routes, just have one process. It will save you some time and energy. So when you want to do the route import between access and aggregation, first you need to determine which routes you want to be exchanged between the access and aggregation. Many times it's just about the point-to-point IPs and even the loopback IPs. So you need to know which prefixes you want to import. Once you've established these prefixes, you go ahead and configure IP prefixes. Don't import everything. Once you've configured the IP prefixes, you know this is the prefix that I want to import, you go ahead and configure a route policy. So the route policy will be merging the prefixes. And then you can now import the routes between access and aggregation using these policies. So the best practices, never import everything between the access and aggregation, always import what is needed. And these are common practice across many protocols, whether you are importing routes from SIS to BGP, whether you are importing routes from BGP to BGP, you still have to use the best practice and not to import everything. Always use route policies to control the import and export of routes between the protocols or between the same between the access and aggregation. Then another thing, you use route policies and prefixes, because once you've identified what you want to import, you use the policies and prefixes to control what you are importing between the access and aggregation. To the next slide, unless there is a question. Okay, another thing that we need to also implement is closing of the access rings on aggregation nodes. So you can see from this setup, you know that we have access process running all the way from SG1 to SG2. It terminates on this node here, and then this one terminates on this node here. So you can see that we have some kind of a loophole here. We don't have connectivity between these connections. So it's kind of, we are having some disconnect in this network. So what we normally do on IPRAN network is we go ahead and extend these access SIS processes between these two nodes. So we'll have a fully operational ring between the nodes on our access and aggregation rings. So this other end, you also go ahead, you know that this process is running from this node to this one. You also go ahead and extend this process between the two nodes and close the rings between from the access to the aggregation nodes. Next slide, unless there is question. Another thing that I've mentioned that we need to put into consideration is authentication for SIS protocol. So majority of these protocols, they support authentication, and this one helps to improve on network security. So if you are just not configuring any authentication for this protocol, and maybe someone knows the point, someone has access to your network and can come up and just connect their routers to your network and then configure ISIS or whichever protocol that is configured between the two, OSPF or BGP, and then the adjacency comes up. He has access to all the information because this information will be forwarded to this device that is not allowed to access the network. So it's always good practice to ensure that you implement authentication for your ISIS protocol, which helps to improve on the network security. So the packets that are being exchanged between the two nodes will be authenticated. You know, before we establish an ISIS adjacency or neighborship, we need to compare the parameters. So the parameters will be exchanged and compared, and then the ISIS adjacency will come up. So whenever you are doing the implementation, it's always a good practice that you do protocol authentication. It could be ISIS, it could be OSPF, it could be BGP, especially for service provider networks. So when we talk of authentication, we can have interface authentication, we can have area authentication, or we can have routing domain authentication. So it depends on the requirements and the standard that is set up by your company. You can do interface authentication. Many times we do, it depends. Many times we can do both interface and area authentication or even domain authentication. You can have all these different authentication types configured on your network. Based on the authentication modes, we can have simple authentication. It's not secure enough. it's insecure because you only configure, like you are configuring kind of plain text password authentication. When someone can do packet capture on your network, they can see the password that you have configured. So still, they can go ahead and do the configuration of ISIS to their device. The ISIS adjacently will come up, and you are not secure anymore with that SIM authentication. So many times we suggest using MD5 keychain authentication or HMAC SHA-253 authentication. The three types, they are more secure and they are the recommended modes that you should be using on your network. So for the best practices, you need to use the same authentication modes and password on all devices in the same area. You cannot implement simple password on one end and then you go ahead and implement MD5 on the other end. And even these authentication parameters, if you configure the MD5 password on one end of the link, you also need to configure MD5 authentication, same password on on the other side of the link. Then the adjacency will come up. If you have a mismatch, the adjacency will fail to come up. So it's always good that you use the same authentication mode and password on all devices in the same area or routing domain. So I've mentioned that you need to merge the authentication parameters, and then it's always good to implement authentication in the entire network. Don't just implement authentication in a given few nodes. Like you have 100 nodes, you only do authentication on 50 or 2, and the others you don't implement authentication. So when you are doing authentication, always implement it on the entire network. Of course, for this one, to change the password, the workload may be huge because you have so many nodes. And when you change the password, maybe the routers have to renegotiate the authentication parameters again. The adjacency may go down. So this one purely depends on the type of services that you have on your network and whether you can allow that downtime for the reestablishment of this adjacency or neighborship. I mentioned that you need to use the CIFAR mode, the MD5 authentication, use the more secure authentication types. Another thing that we need to consider is on how to improve the network convergence speed of our network. We know that, for example, a carrier network will be having many devices, thousands, 10,000s of devices. So you need to consider the network convergence speed of your network. So how does ISIS converge? First, we need to establish relationship. So you will configure ISIS. We need to have adjacency or neighbor relationship established between the two nodes. And then we have LSDB synchronization. Once we have LSDB synchronization, we'll go ahead and have SPF calculation. Once we have had the SPF calculation, that's when we can now install these routes to the FIB, the forwarding information base. And once now these routes are installed, that's when they can be used to forward traffic. So you can see that it's a kind of a process that takes place for the ISIS protocol to converge. And if there is a failure in the network, so when there is a link or node failure in the network that is running ISIS, we also have to complete some procedures before switching traffic to a new link. So when there is a failure, of course, we need to detect that there is a failure. There is a link failure, there is a node failure. How quick do you detect the link failure? That's why we brought in the BFD, like bidirectional forwarding detection, so that you can quickly detect there is a node failure or a link failure. And once it's detected, it's communicated to a protocol like ISIS. So when there is a default fault, it has been detected, you need to update the LSPs and then flood these LSPs. You need to calculate the routes and then you need to install them in the forwarding information base. So this is just when there is a fault, and then when you are just doing the implementation, that the standard process will be this one: establish neighbor relationship, LSDB synchronization, SPF calculation, the routes installed in the routing table. But when there is a fault, first you need to detect the fault, update the LSPs, flood the LSPs, calculate the routes, and then install them in the FIB. So there are different mechanisms that can be used to accelerate ISIS convergence. Some of them are inbuilt. For example, when you talk of ISPF incremental SPF, you have the PRC, partial route calculation, and then you have something like fast LSP flooding. So these are just some mechanisms that you need to ensure that they are implemented on your network to ensure that we have faster convergence. We are reducing that downtime of our networks. Next, others, you can configure the intervals for detecting link or device failures. For example, the hello packets, you configure the interval at which hello packets are sent. You can configure the number of hello packets that are sent before the local device consider the neighbor is down. You can configure dynamic BFD for SIS protocol to ensure faster fault detection. You can also set the flooding parameters for SNMPs and LSPs. For example, you set an interval at which SNMPs are sent. You can also configure the intelligent timers to control LSP generation. You set the size of an LSP, you set LSP update interval, you set the maximum lifetime for LSPs, you enable LSP fast flooding, you set an interval at which LSPs are retransmitted over point-to-point link. You can also configure automatic SIS LSP remaining lifetime adjustment. So these are just some mechanisms that you can use to ensure that your network converges faster when there is a fault on the network. You can adjust SPF calculation interval. You can also configure convergence priorities for IPv4 SIS routes. So you know that there are some routes that are of high priority. You can set the convergence priorities for these routes. You can have mentioned that you can configure SIS intelligent timers. You can configure auto FRR, fast reroute. And then using the point-to-point network types also helps to improve your network convergence speed, because you don't have to elect the DIS or the DR on your network when you have configured the point-to-point network types. Any question up to that? We almost reaching the end of our session. Any question before we finish the few remaining slides? Are we still there?
Yes, of course, of course.
Yes,
Yes.
still.
Any addition? Anything of
Martin, can you go back one slide? I have a question.
one slide on which one?
There.
Yes.
Yes. So most of those things, those adjustments, it's based on setting parameters, right?
Yes,
So
yes.
where are those like from a design perspective,
Yes.
where do we get those values for best practices? And I'm sure perhaps it's supposed to be across the network, right? Like uniform, something like that. But where do you get the recommended values? Are there some, okay, I know for Cisco they have some validated designs and all that, but for Huawei and Nokia, do they have also those recommendations
Yeah, I think they have
or
them.
values
Of
to put?
course, yes, you mentioned different vendors could be having different standards, like the best values that you need to set for these different parameters. So maybe I can check for Huawei and Nokia and try to include them on the PPT before I share it out. Will that be okay?
Yes, that would be helpful. But even if you share the PPT and you share those documents, the links to the document in the group later, it would still be fine.
Okay, okay. That is okay. Any other question or any other comment or input from any of the attendees? Okay, so the last slide of our presentation today has sample data preparation. Of course, there are other many parameters that I haven't captured, but we'll capture them when we are doing the lab simulation, because we'll have a lab simulation. We'll have a separate session where we'll now be doing the implementation of how you need to configure this protocol on Huawei and Nokia. So these are just a sample data preparation that you need before you start the implementation. For example, the ISIS area that you will be configuring for your access and aggregation, you need to be very clear, especially for a new network. Even when you are doing addition of a new node, you also need to know like this node is connecting to which node and which IGP process is running in this existing node before you can go ahead and implement the integration of the new node. So these are just some data that you need to prepare. You need the loopback IP address. You need the ISIS system IP. So you have mentioned that many times we generate the network entity, the system ID from the loopback IP. How do you generate it? You need to be able to prepare this data before we can go ahead and do the implementation. The sysname, you need the sysname. I've mentioned that this one, when you display the ISIS adjacency and you have configured the IS name, it's very easy to tell this session is established with this neighbor, is established with this node, so it becomes very easy. And then ISS level that we'll be using, for IPRAN network, we normally use level 2. All routers are backbone routers. Cost style, we go with wide. We don't use narrow. I think Theo has mentioned that for the narrow, we only have 0 to 63. But for wide, we have almost, is it 0 to, is it 1,600,000 and something or 16 million? Not sure about the figure. And then the network type, we have also mentioned that you normally go with point-to-point connection. We avoid using the broadcast network type. Someone has a comment or please mute unless you have a question. So you need to prepare this data before you go ahead to do the implementation on the IPRAN network. And yeah, the floor is open for questions.
Hello, Martin.
Yes, yes,
So, can you go back to slide 28, please?
yes,
Yeah. So, from what we have discussed, looks like the data obviously is a bit inadequate, right?
yes,
We, so I wanted to ask, was it like this is based on a particular design that for the upcoming lab or something? And then the second thing I
yes,
was going to ask, during when you were showing a design and talking about segmenting the access and aggregation,
yes,
you put there some ISIS adjacents was at level one also. I saw it in the slide if I'm not mistaken.
yes.
But now put here that we need to have all level 2, like to clarify my thought, because I was thinking earlier in this other slide that for those routers would all be level 2, unless I'm mistaken.
Okay, for the sample data, of course, this is just a sample. We cannot have all the parameters. I know there are many, many other parameters that you can include in your data preparation, but you see, there are some of those parameters are always standard. For example, when you talk of the hello timers, the dead timers, you see, your network can still operate okay with those parameters unless there is a special requirement. That's when you will go ahead and change the parameters. I hope you're okay with that. So there are so many other parameters that you can include that I haven't included here.
And then
Okay.
to add on to that a little bit, when you are setting up ISIS, he mentioned that at the core we use level 2, but I think that that application applies more like at an enterprise level, because by default level 2 routers cannot import routes to level 1 router and vice versa. So that's why you need level 1 2 router in between. It's why you saw level 1 2 router in between level
Yes,
1 and level 2 routers.
yes, I agree with that. The reason we had this slide is just to make us understand the different levels that we have for ISIS protocol. It was just an overview of the level that we have, but the one that we normally use, I've mentioned that we use to, we are using level 2. But this one just represents the different level that we have in ISIS, level 2, level 1, 2, and then level 1. But many times when we are setting up our network, we stick to level 2. So all routers will be backbone routers and they should be able to exchange the routing information. I hope that's clear.
Yeah, it's clear for me, but the person who spoke earlier said we should have level 1, level 2, I think, as well. I don't know.
No, I think he was also asking a clarification why I have put here the area to be like the network type to be point to point, but again I had mentioned about level 1 and level 2. So this one was just to make us familiar with the different types of levels that we have in ISIS. But even on this slide, I mentioned that we always go ahead and configure level 2 in our networks. Any other question? The floor is open for questions.
I'm asking about a net in ISS and ISIS.
Yes.
Like OSP for router ID,
The network.
area ID.
Yes. The network. Which one?
Like OSPF area ID.
Yes. Come again.
A net in IS, like area ID in OSPF.
The kind of the network entity almost identifies like the area ID. Because you see, we are using, when you check on the format of the ISIS, let me just go back to the slide. You will find that, of course, we've talked about, let me go back to that slide. You see, we have here the area address, and then we have the system ID, and then we have the selector. So you see, many times we'll find we have something like 49.001. This one could be like the one could be the area ID that you will set up. You can have 49.00100 or 0010. So this is kind of the area ID we are talking of. And then of course we'll add the system ID and the selector.
Yeah, good. Thank
Okay.
you.
Any other question from the team?
Yes,
Yes.
yes, Jija.
Yes.
This course IPRAN, can you add for the USG?
USG, no. You see, on IPRA network, we rarely have firewalls because the firewalls are always part of the core network, the IP core. That's where we
Okay.
have the USG. I know USG, that is the Huawei firewall, right?
Yes.
Yes.
When finish this course, the IB core start.
We will see. Let's first finish this IPRAN first, and then because we still have multiple sessions, we still have a few sessions to cover. We haven't covered the labs, we haven't covered BGP, we haven't covered the QoS, such like
Okay.
QoS, we
Okay.
haven't
Thank you.
covered the service design and implementation. So we still have some
Ah,
sessions to
yeah.
cover before we can go ahead and start another
Okay.
session. Yes.
Okay.
Yeah,
Okay.
so just a quick
What's
question.
the perform the BFD? How
Yes.
to BFD?
What is the issue about BFD?
BFD perform BFD. Yes.
Yeah, I've mentioned that when we are doing the implementation of the IGP, we normally go ahead and implement bidirectional forwarding detection, BFD, so that we can speed up the detection of failures. So when we are doing the lab, we can have that one demonstrated how to implement BFD for ISIS.
Thank you.
Yes.
Thank you.
Yeah, another quick question. Should we be able to simulate this on maybe like Huawei's ENSP? And if so, what type of routers are we going to be running? Is it going to be the NE, the net engine routers? Because those ones are quite heavy. I think that's it.
Yes, if you have ENSP set up, you can just, these are just basic configuration. You can do them on the normal AR routers. You don't need to run the NE net engine or the CX routers for you to be able to simulate these basic. You see, these are just some basic functionalities which are supported by almost all routers. So you can just use the AR routers. You should be able to do the lab simulation on it. You don't need the CX or the
Okay.
net engines.
Okay, thank you.
Any other question?
Yes. Did when you use the ENSP lab, the NE40 support for VSI, but the router default not support for VSI.
Yes. Some advanced features are not supported on the AR router. That's why you need to set up the net engine or the CX router that you should be able to configure all the other advanced features on Huawei routing or switching devices.
How to solve this issue when you upload the NE40 and 900, 9000 and, and other softwares. When you click the NE42 routers, the computer is busy or request timeout. How to solve this issue?
And that one purely depends on the type of machine that you are using because, yeah, if you have the resources, you have the CPU and the memory, they will definitely boot up. But if you have a laptop with less memory, less processing
For
power,
example, my PC for Core i5, not the RAM is a 16. There is some issue to increase my the capacity or RAM.
yeah, unless someone has a different comment, but for me, I feel it's always depends on the machine that you are using. If
Yes.
you
Okay.
have a
Thank you.
very good heavy machine with the CPU and memory, they will
Yes.
open. I've done that and I haven't had issues. Of course, they take time to boot, but they finally boot,
Yes.
and then you can do your lab simulations on them, both for
Yes. Thank
CX
you.
and NES. Yes.
Okay. Thank you.
Welcome. Any other question before we close?
Okay, in that I have two questions.
Yes, James.
First one is about the carrier network in general.
Yes.
If we have some organization that do auditing for the network to check if the architecture meets the standards, if the configuration meets the standards, if the security meets the standard, if we have this, I'm not sure about this part.
Yeah, there is always there is no one who will come to check on the architecture, but for the security part, of course, it's always a requirement, even for I mean, for these service provider network, they will be checked. Like you need to implement the security measures. So the security aspect is always checked, and every service provider, be it a carrier or even this enterprise, they will always have requirements on the security aspect to ensure that yes, we have this authentication implemented. You see, they also have a requirement from maybe let's say the communication authority to ensure that they meet such requirements. So we'll always have an audit on the security aspect. On the architecture, I don't think there is anyone who will. You see, when you implement the standard architecture, it's very easy for the operation and the management of your network. If you just come up with a very funny architecture, you end up having issues in your network, and it's very hard to troubleshoot and even operate and manage your network. So the
Oh,
architecture, it's more of internal thing, and it helps in improving the operation, the management, and even the scalability of your network. Because when you want to expand your network and you have very funny setup, you see, it's very hard to scale. But if you follow the standard architecture, of course, I've mentioned there are variants. Sometimes you need to connect the BTS to the RSG. That one is allowed. It's kind of standard. But you can't just come up with a very fun topology, do the implementation, and you may have many issues to handle for your
Okay.
network.
Okay, so we do have network audits. This is yearly.
Yes, network audits are done continuously, not specifically yearly, but they are done continuously. It's a continuous process.
Okay, okay.
It
So
could be
this means
done, yes, it could be done quarterly, like Q1, Q2, Q3, Q4, you do continuous auditing.
now this means things like you talked about IS authentication.
Yes.
So this means it's not just not good to implement. This is a must to implement to avoid some trouble during auditing.
Uh,
Okay.
of course, it's good. It's good. It's a good practice, and we always try to stick to the best practices when we are doing the. You see, when you have mentioned that when you do the good practices from the start, like let's say, for example, you've set up a network, you've clearly indicated that we need to have authentication on this network. You see, when there is a requirement that you need to implement authentication on your network, you don't need to start bringing services down because you want to implement authentication. No, you will already have it in place. You are only insisting that for any new node coming in, should also stick to this standard.
Okay. My second question is, this is our second maybe session for IPRAN.
Yes.
And I can see that at least you need to have some basic
Yes.
for you to really benefit from the session. I'm asking for the case where we have an newcomer in the technology. If we can organize some other private sessions so that you can fast track a learner's ability, if this is possible.
Yeah, that is possible. That is something that we as Lifey Technologies we are offering. If you are interested in one-to-one sessions, we can have them. Of course, that one is a separate topic. Only we discuss when you are interested. But if you really want to, of course, for the IPRAN session, we are more focusing on the on the application side of the protocol and not really on the nitty-gritties of how these protocols operate, how to do this and that. But if you want to learn the basics of networking, yes, there are sessions, one-on-one sessions that can be planned, organized, online sessions, so they can be offered to anyone. Just need to align on the times, and the sessions are always flexible, so that yes, we don't interrupt your normal schedules. So they are available, and yeah, if anyone is interested, can ping me, and then we can discuss further on how to do that.
Okay, that's great to know. Thank you so much, Indeche, for making up your time to share knowledge on this IPRAN technologies. Really appreciate the effort you're putting in.
I appreciate your presence too. You know, it cannot happen when we are not here. So I appreciate everyone who also takes time to join the session and also to participate actively to ask questions. It's also a learning process for me because when you're asking me these questions and we are discussing, I'm also getting to interact with different networks. We know what is implemented on other networks. Maybe we have Airtel Congo, Airtel Nigeria. We can know what they are implementing. We know they are planning to implement IPv6, SRv6. So you know it's a learning process for both of us, and I appreciate it also.
Okay, please, the next session is planned for when? Because I think most of the guys here miss the first session. I don't know when the first session happened.
Sorry, I dropped. Hello. Hello.